Hello. Good evening and good evening. WeatherBrains 621. This is the pre-show, that marvelous time of the evening where we share boring personal stories, humorous anecdotes, and occasionally say outrageous things. So we have a lot of absentees tonight, but Kim, I am so glad you are here.
Yeah, man, me too. I was looking through the absentee email roll call. Is it pretty much you and me tonight, James?
You, me, and Aubrey, and I think that's it. So wow.
Yeah, wow. And we have a guest host. We'll be having Mark Jellinek joining us to help us out.
So yeah, I've got all these fancy notes here from Bill, so I need to.
Yeah, right. I know. And tonight
let's see if we can get Patrick in here first. Everybody loves Patrick. Here we go. So Patrick has now been invited, and let's see if we can bring in Mark. It says email the link to both he and Patrick. Oh, Patrick was not seeing the invites. Well, okay. Well, let me try and invite him the regular way. And for those that are watching, we use Google Hangouts. It's always an interesting project every week getting our guest online. We've learned the higher the IQ of those that are on the show, the lower the odds of them figuring this out for some reason. It's just amazing. So
that is true. That is true.
PJ. Better not say this on the air in case they want to keep their email private.
Now, were we going to get a 2-for-1 with Patrick and Steve Weiss, or was Patrick just the mechanism through which we were going to get Steve tonight?
I think Patrick was going to kind of set up Pat or something according to one of these notes. I'm hoping Patrick comes on the show.
Yeah, that'd be great. We would love the extra weather break tonight.
Both of them have been invited the regular using. I think I guess I send them the YouTube page for the show. Do that. So yeah, typically Bill Murray does all this, and don't have to worry about it. So let's see. First off, let's do Patrick.
Oh, we have Mark. Wonderful. Hi, Mark.
Hey there. How you doing?
All right. How are you?
Doing well, thank you.
Great. We're excited to have you join us as a guest WeatherBrain guest panelist this evening, as many of our panelists are out with family crises or concerts or other kinds of fun stuff going on in their lives tonight.
We don't like to hear the word crises with family involved.
Yeah. Well, we'll have to hear later from Rick what the issue is with his daughter. She apparently is having some car trouble. What's going on in the world tonight? So, Mark, where are you joining us from?
I'm sitting in, well, technically I'm sitting just north of Atlanta, Georgia, but for all intents and purposes, Atlanta, Georgia.
Wonderful. Exciting night in Georgia, huh?
It's, well, by this, last 7 days, it's a rather boring night in Atlanta compared to what last Friday was.
Mm-hmm. Let's see, we have Patrick in. Oh, there we go.
Record. Hey, Kim, this is Steve.
Hi, Steve. How are you?
Looking this way, is it? I'm looking kind of shady, aren't I? But that may be very fitting. Shall I move things around so I have a little more light on me, or is that going to be too frightening for people? Let me try this. Oh, hey, Patrick. How are we going to do this? What's the best way to get lighting? I don't want to. Does that work? Sure. How's that?
They're the ones you can see.
Well, you're the ones that are going to have to decide how much you want to see.
I mean, it really is up to you. Right now, you're just sort of looking at us dead on like a normal conversation. Before, you were kind of looking down on us. So whichever approach you feel you'd like to take, you just take whatever you want to do.
Oh, okay. Well, that'll give me a lot of freedom. We can always be flexible on every half hour.
That sounds good. Is Patrick going to hang around?
Patrick? Patrick is supposed to be working shift, but it's a relatively quiet night. Patrick, do you want to hang around?
They can, if they want me on, I will hop on. But either way, I'm fine.
Can you hear him? He said if you want him on, he can act like a bunny and hop on.
Well, Span just mysteriously disappeared. I hope he comes back. Patrick, we seriously are missing many of our weather brains tonight. If you would like to join us, I'm going to use executive privilege as the person that Bill Murray handed the baton to. And I would say I'd love to have you join us if you're able.
My only hesitation is I don't like the precedent of setting I'm on shift and I agree to do the show. It's one of those, it muddies the line between doing public, being
Right.
I'm a forecaster and then showing preference to various things. So
What might happen is he would have to.
I then have to go on every podcast.
Or he'd have to relinquish some of his salary for tonight.
Oh, yeah. Well, that's a high
Yeah.
price to pay.
I mean, Patrick would probably volunteer to give some of it up, right?
Not with number 2 on the way.
All right, we'll take that one back.
Kids are expensive.
Yeah.
Mm-hmm.
All right, hey, Patrick, come around here for 1 second. I don't need this, do I? I just press it. That's right.
There you go.
Okay. All right, we're good. We're
Okay.
going to have to see how this works because a lot of times I kind of move around in my chair and we'll see how it works. You can always contact Patrick secretly and he'll come in here and straighten me out.
I'm going to be watching from ops, and so if something comes up.
Oh, yeah. That's cool. Well, the lighting still seems.
You got the secret
Crummy.
list of questions, right?
The secret list?
Look at the.
Yeah, the questions that all the forecasters want to ask.
Yeah. It's like,
Patrick, I'm
oh,
just
my
upstairs.
God.
If you want to come hand me something, just one floor up.
Oh, where are you at?
I'm in Chuck's old office, Chuck Doswell's old office.
Oh,
Does he know?
Okay.
He does. Yeah. Oh, yeah. I think he's actually seen it.
Okay. So
I'll be out here.
Sure. Maybe I'll come around.
I
this
never
way.
knew you had Chuck Doswell's old office.
Oh, yeah.
Wow.
Oh, it's an honor. It's an honor. Every day I walk in, you just feel a bit of the Chuck experience.
Yeah, the aura.
He's here.
The aura.
Hmm. The aura never will leave this room. It is forever.
Does he have any cowboy hats in there that you could wear? That would just really make it look good.
I was really sad that there were no cowboy hats that were here when I inherited the office. I at least expected he had, at one point in his office, every single conference badge that he'd ever had from any conference he'd ever been to was sort of draped around in here. And I expected to
Wow.
find one behind, the shelves or something. But sadly, he did a pretty decent job. He cleared out everything except for this wonderful 1970s or 80s era wood paneled extension cord. I didn't know that they made them wood paneled.
Wow.
It was truly something. It was delightful. But that's what he
Wow.
left me.
Okay. So Patrick, you're not going to be on the show with us? I mean, come on, man.
Patrick has already departed back to operations.
He's left the building. Wow.
He has gone into another section. He's still in the building.
Well, he's back there laughing at us now, probably.
I'm sure of that.
So, Steve, we owe you one for doing this. This might be the worst hour of your life, but with Kim being on the show, it's going to be okay.
James, I have had a number of interesting hours of my life if I think back. And if this is the worst hour of my life, I've had a pretty good life.
So how far are you two physically? So where is Doswell's office in relationship with the SPC office? How far away are you guys?
Different floors of the building.
Okay. We're one floor apart, and I'm almost right over the forecast office, but not quite, but very close. So it'd be delightful, Steve, if I was just directly over you, then you could just, if there's a question I was asking that you didn't like, you could do the like banging on the ceiling thing.
We could have a fireman's pole.
Mm-hmm. Oh.
And either you come
like
down
they do.
Or I come up. Huh.
Well, if we could break into the climate survey, we could go ahead and do that. They have a poll back there. Get down
That's
to the
the show
decade.
title right there. They have a poll back there. And so we can't start the show until 30 after the hour here, and then we're going to hit in about a matter of seconds. And once we do that, we'll get this thing started. Mark, you okay? You say you're over in Atlanta?
I am indeed over in Atlanta.
Awesome.
I have melted.
Yeah, we have melted. That was a debacle. Wow.
Yeah, there's some unhappy folks. I mean, I know Glenn Burns. Being around as long as you have in the broadcast side, but he voiced some unhappiness with the National Weather Service office here publicly, which I'm not used to him doing. So,
really,
yeah,
really.
Ryan Maui put something on Twitter, and Glenn said that, specifically called out the NWS office in response to something that Ryan put up. So,
ooh,
yeah,
well,
I was
we
surprised
need to
to see
that.
Yeah.
No, I Glenn and I, we've been in these markets forever, and
right.
And by the way, let me welcome our television viewers. It's 30 minutes after the hour. Thank you for joining us. You know what this is. This is the pre-show of WeatherBrains. We're about to start the show here in a matter of seconds. In fact, let's just start the show right now. Let's just do it. We're all here. So we're going to hit recorder number 1 for one track, recorder number 2 for the second track. And here we go in 5, 4, 3, 2, 1. This is WeatherBrains episode number 621. WeatherBrains is the weekly show that's all about weather. This is for December 11th, 2017. Getting off the coast Christmas time. And goodness, Kim, it's just the two of us. How did this happen?
The two of us. Apparently, everything goes wrong in early December for all of our other panelists. We've had all manner of issues tonight with everybody else.
Now, every excuse known to man has been thrown in here. We have Brian Peters, who is the internationally beloved meteorologist, former WCM with the Weather Service office here. Brian is a poll worker. Poll worker? Is that the term here? He works the elections. We're having this, nationally known election tomorrow, and so Brian has to get up at like 7 o'clock or something, or 6 o'clock. And he doesn't come on the show. I get up every morning at like 4:30, and I'm on the show every week. I mean, come on, man. But so Brian is out. Rick Smith said it was car problems.
His daughter's having car trouble.
Oh boy. Well, that's understandable. You got to take care of the daughter.
Mm-hmm.
Bill Murray is one of his children is having a concert. And Kevin just mysteriously vanishes. He doesn't explain, but at least he told us he's not going to be here. And Aubrey, I don't know where Aubrey is. I want to be sure. I'm going to invite her one more time, but hopefully she'll join us in a minute. But Kim, let's bring in our guests, because the guests will make the show good this week.
They sure will. Yep. We don't need that many of us when we have such high-powered guests with us. Tonight we have guest weather brain with us, Mark Jellinek. Did I say your last name? Is it Jellinek?
It's close enough.
I have a name that's often mispronounced. It's been a fun topic of conversation on the show. How do you pronounce it?
I pronounce it Jellinek, but I've heard enough variations over the year where anything close is acceptable.
Wow, Jellinek. Yeah, well, I can empathize with how often that probably goes wrong. My name happens too. Welcome to the show. And you said that you're from just north of Atlanta, Georgia this evening.
That's correct. So sitting just on the outskirts of Atlanta, Georgia this evening.
Yeah, so you guys have had some fun weather there the last week or so, huh?
Yeah, it was an interesting event. There's no doubt about it. We went from we're not going to have any snow to, and it was a bit unusual. Usually when there's talk of snow, they cancel the schools and leave everybody home. But nonetheless, they sent everybody off to work in school on Friday. And then about 2 hours into the day, they decided, whoop, time for everybody to go home. So it was actually more chaotic because all of a sudden everybody was going home at once. And, parts of the city on the west side, north side of town got almost a foot of snow. So it was a pretty substantial event for we're not sure sort of thing.
So wait a minute. I got a horn in here. So let's talk about the forecast error and finger pointing. So you're saying, Mark, that after the event, which
Correct.
was under forecast,
or even still during the event, maybe even
so there was some finger pointing going on within various members of the weather enterprise in Atlanta. Huh? Tell us about this.
You're going to try to put me on the spot. If I'm trying to recall,
that's what we do on this show.
I know. I was trying to call up the tweet that I saw from Ryan Maui because he specifically talked about his initial impression about the quality of the forecast that was done. And one of our longtime meteorologists in the market that, certainly anybody in Atlanta will know is Glenn Burns. And he expressed in a reply to that tweet let's just say some dissatisfaction with the local National Weather Service office. I'll try to pull the tweet up here because I don't want to put words in anybody's mouth. But, I've gone back. I even tweeted about it today. It was certainly a tricky situation. The challenge, as we all know, with these storms, particularly in the South, is where does that line set up? And the banding, we had a band just on the north side of town that was in that freeze area. And accordingly, we got a big event. But it reminded me a lot, and that's what I said in my response to the Twitter, of Hurricane Harvey this year. We had these forecasts, the model forecast for over 40 inches of rain around the Houston area. But, whether it's me or any other meteorologist, we have a hard time a lot of times believing the models, especially when they throw things up there like that, because a lot of times they're not always right, as we know. And I think a lot of that happened with this event as well. So, I don't think anybody wanted to believe 40 inches of rain with Harvey. It felt odd. But when you put a half a foot snow event in Atlanta on a single digit day in December, I mean, there's no precedent for that happening. So I think people were slow to say, okay, we're seeing this shift move in the precipitation moving north. And so I think it was a hard buy-in for a lot of folks. And there was a lot of people, Chris Holcomb, who is a meteorologist here on another station, is a friend of mine. And I mean, he issued a public apology on Facebook and talked about what happened, but said, hey, we got it wrong. And owned up to that, which, is not an easy thing to do. And is tough to admit when stuff like that goes bad.
Did you feel
the deal here? Go ahead, Kim.
Okay, well, really quick question. Did you feel like there was a lot of consensus among the weather enterprise about the forecast? Did everyone generally agree about where the snow line was going to be and how much snow there was likely to be, or had different camps evolved as the event neared?
I think the issue with most of it is most folks were downplaying the possibility of snow the day before the event. But again, if you look at the models, the 12Z run from, let's say, Thursday morning, so the day before, 24 hours before the event started, it didn't look like a big event in most of the model projections, but it was during the course of the day that line was shifting north. And I just don't think people wanted to jump on that. So again, there wasn't enough change to stop people from saying, hey, let's cancel, let's close schools for the day. Let's keep people home. And I was stunned. I mean, I was watching people getting ready to get on a bus to go to school, and there were snow flurries already in the air. And for Atlanta, that is just not a mix that usually happens. Usually, everybody's bought all the bread. Everybody's brought all the milk in the grocery stores and have called it quits and are staying home. So just wasn't what was going on.
There was actually good agreement in the weather enterprise here, Kim, in this market, and we pretty much had the same situation Atlanta had. The day before this event, and the event happened on December the 8th. And let me say this too, that what we have a collaboration chat. I don't know if they do this in other markets, but we have the WCM, the SU. Now, we don't have an MIC right now. We might not until after I'm dead, but we have the WCM and we have the SU of the Weather Service and the chief meteorologist for all the TV stations on a chat. And that's the only people that's on this chat. This is not the standard Weather Service chat. And we try and exchange ideas and argue our points and come up with a simple, unified message that we present to the public. We'll communicate it differently, but the idea is to be kind of on the same page. And unfortunately, the page we were on the day before, on December the 7th, we said snow is likely. We're expecting amounts up to 1 inch. Maybe a little more in some of the high terrain on the eastern side of the state. But the bottom line is the message we sent the day before was for about 1 inch. In the middle of the night, when it became obvious that this might be more than that, it was up to 1 to 3 inches. And the bottom line is on the high end in my market, we had 15 inches. And this is not Buffalo, New York. This is not Cleveland. This is not Chicago. This is Birmingham. And wow, you talk about a bust. And we had at one point 60,000 people with no power. We had a lot of issues with that. So we fouled it up. And I wrote a piece on it. The one thing I think where we fouled up, we were guilty of staring at these computer models. Models, you know, they're fine and they're a marvelous tool. But when this thing is so close, look at your analysis. Look at the actual upper air data. Look at the surface analysis and look at what's happening to the west. And the thing was clearly overperforming in Texas. I mean, it was dumping tremendous amounts of snow in places that were forecast to have snow. And we should have had a clue from that. And the other thing was climatology. You know, like Mark said, we don't have big snows here in early December. The odds of that happening are very, very remote. And we had soil temperatures that were in the, low 50s. And traditionally here, when it snows, even if the snow rates are pretty impressive, most of it melts. So with all this in play, we just went for the 1 inch scenario, but live and learn. So what you do, you learn from your mistakes. Talk to the people, be honest, and you move on. So that's what, and I didn't mean to get bogged down in this, but it was kind of a big topic down here. So it is what it is. But the thing we try not to do here is, point fingers at the Weather Service or they point fingers at us. We try and be on the same page. In fact, we had a mini workshop earlier in the week where we were all together at a local EMA office and, talked about things. So anyway, Kim, I'm sorry. Bring in Steve. Steve's our big star on the show here. I can't wait to talk. I got a million questions for the guy.
Wonderful. Well, I'm very pleased tonight to introduce Steve Weiss, who is coming to us tonight from Norman, Oklahoma, one floor away from me. He is the branch chief of the Science Support Branch of the Storm Prediction Center, and a man who generally needs very little introduction. Steve, welcome to our show.
Kim, thank you very much. I appreciate the invitation, the hospitality, and we're going to have a good discussion and have more fun tonight. I think what James brought up and what Mark brought up already really points out some of the challenges that we have within the weather enterprise, especially as we're dealing with potentially high impact events, but we may assess them as having a low probability of occurring. And this is a challenge that's going to continue to happen because lots of these events can be relatively small scale in nature. I really like what James was talking about in terms of having this tag up among the different chief meteorologists and the broadcast media, along with the Weather Service, to work together to try and come up with common messaging or at least common information. And by forming a consensus, we have a better chance of being correct. This case pointed out, maybe not, but it just shows that we continue to have challenges and the atmosphere can be very difficult to understand at times.
Yeah, absolutely. I mean, something that this event made me think about, and actually, James, you added a really interesting nuance to this, is with the fact that I really don't know that this event was really on anybody's radar. But in many situations, you have the, are you good, Steve?
Yeah, I'm good. Patrick came by and said, put these earphones on. It'll make you look better.
He's right. You look snazzy. You look flat out snazzy.
I'll tell you, I may have to keep these on all the time.
Yeah, that would be great. That would be great. It's a real fashion statement. So the thing that this event made me think about is in so many events where you have this low probability but high consequence potential outcome, and setting aside for the moment the fact that in this event that outcome wasn't necessarily even really on anyone's radar. Many times there is sort of that outcome on people's radar. You face this in the SPC. I know in the South, you all face this every winter with events that are maybe most likely not going to turn out to be a catastrophe, but there's an outside shot that they could. When you have these organizing principles where you try to come together around one message, do you all feel like that maybe excludes the low probability in favor of what you might think is the most likely? And so you focus on that and maybe not emphasize as much this unlikely but potentially highly impactful outcome. In other words, does this drive toward consistency make you hone in on one message rather than maybe a couple?
Here's my opinion, Kim. I like what Jason Samenow and the guys at the Capital Weather Gang do, and I'm seeing some other people in the Weather Enterprise do this boom or bust thing when it comes to winter weather events, where you forecast up to 1 inch, 1 to 3 inches or something. But they have a boom, forecast where on the high end, this might generate 1 foot. On the bust end, nothing, not one single flake. And I think we probably need to look at doing something like that. And again, in a unified way, if we can, where people can see the range of possibilities, even though these are very unlikely. I think we need to throw it out there. And I just think that is a good way. And again, it's more of a social science question. We've never done that here in the past, but I think it's something we need to look at, a boom value and a bust value.
Is that something in the South? There's really not that in the broadcast markets, in the Weather Service forecast offices and their messaging, that's not been something that's been done? No.
What I say when I come on here, the first thing I'll say in a situation like this, number one, there is a limited skill set down here, a very limited skill set. There's a lot of things we can do, and there's a lot of things we can't do. When it comes to forecasting winter weather events, we just don't have that much experience. We're in the deep South. It doesn't happen a lot, and there can be great errors. And if you're working with old forecast information that's more than 6 hours old, it's bad information. But understand the lack of confidence in forecasting any winter weather event. We try and communicate that, but I just think we need to go to the boom and the bust numbers. And I'm seeing a lot of more and more people doing that. And in a case like this, understand that the models were printing out these outrageous values. They were printing 5 and 6 inch amounts. Did they print 15 inches? No. But they were printing 5 and 6. And, we probably would have gone something like that. And the other thing, let me ask you this question, Kim. So let's say that we were just magicians and we're like Steve. We never get a forecast wrong. Steve is a genius. The man never gets a forecast wrong. And we knew in advance we were going to see some spots with 15 inches. Can you imagine the public's reaction? Mark, it's like that in Atlanta. If I went on television, or if Glenn Burns went on Channel 2 in Atlanta and said, we're going to see 15 inches of snow, people would freak.
Yep.
They would run for Miami or something. I would be afraid of the public reaction. I mean, how do you communicate that? Without instilling panic down here? I don't know.
And I think that's very true. And I guess that would be my question back to you. If you had the choice of going on the air and saying, we think there's a good chance we're going to have 6 inches versus what happened, do you think people are more forgiving I think they are in the South. I think they're more forgiving if you call for it and miss than if you do what happened here, which is, all of a sudden, it was utter gridlock. No one, and the thing was, it was melting, but the rate it was coming down at, people were really panicked that they were not going to get home. And
how did everyone fare in those cities compared to, was it 2014 that there was sort of that the big Commutageddon or the other event where everyone had to run
very
home?
Different event because the roads never were problematic for this event. So
Okay.
the rate of snow was very impressive. And I mean, that's kind of, it was more scary than it was reality, because anybody that waited, and I was walking around and I talked to somebody and he was saying, I think I'm going to wait. I said, you'll be fine. And he waited for 2 or 3 hours until the roads finally did clear. And then he was able to go home without any problems at all. So the roads generally stayed clear even through the overnight, because we hovered slightly above freezing. But when you get 6 to 8 to 10 inches, it just can't melt that quick. And so people were seeing all this stuff stacking up in the side, in the grassy areas and all that stuff. And it creates a bit of a panic in that just visualization. But I still think they would have preferred to stay home and for the snow event to have not happened than the other way around.
That's interesting, because over in Birmingham, our folks had a delay. Everybody delayed. The school systems had a 2-hour delay, which gave them the option to cancel, which of course they did, about an hour into that 2-hour delay. So I was surprised Atlanta did not do that, which is interesting. But most, and again, our roads weren't that bad. Like you say, the roads were just wet. And the impact was nothing like that 2014 debacle. But I agree. I mean, looking back on it, we probably should have hit it a little harder, because I think people are more forgiving if you forecast 6 inches and you wind up with 1, right, instead of the other way around. But again, it's all social science, Kim. We're going to learn from you. Somebody's going to write a paper about this one.
It's very interesting. I mean, what you're talking about, that it's the asymmetric penalty function. That is the reason why we prefer to have, more false alarms for tornado warnings, something that Steve's intimately familiar with, the tornado problem. It also happens, especially in private sector forecasting for rainfall. There's a systematic wet bias, so an over forecasting of rain because of this asymmetric penalty, which just means that missing the event has more significant consequences for people than forecasting it and having it not occur typically. So Steve, in your career, how have you seen this in your own work in severe weather forecasting?
Oh, very much. What you call the asymmetric penalty function, we have been aware of a very long period of time, especially for critical events such as tornadoes, if they're striking a populated area. If we forecast severe and it doesn't happen, we don't like that, but that's clearly preferable to forecasting no severe and then having severe weather occur. The impacts, the economic impacts, the societal impacts on people can be very substantial when severe weather strikes. And we would, if we're going to err, we would rather err on the side of caution and have a forecast out than not have a forecast out and then something happens. So that's something that we have been aware of for quite a long period of time. I'd say this became evident back at least in around 1980 or so.
Mm-hmm. Well,
from our experience.
Absolutely. Well, with that in mind, I actually think this is a great transition to open up the floor to you to talk a little bit about your experience and what has your career trajectory been like? Where all have you been? How long have you been at SPC? And what brought you there?
A very long period of time. I was interested in severe weather, both thunderstorms and snow, growing up as a kid in Chicago. I became fascinated by weather. I decided, I think by the time I was 10 or so, I really liked weather, and I wanted to keep at it. I kept weather records from where I lived, and went into meteorology as an undergraduate, decided I really did like that field of study. I was very fortunate as an undergraduate to spend 2 summers at the old, and this will give you an idea how long I've been around, at the old Weather Bureau District Forecast Center in Chicago.
Oh, yeah.
Back in the, before we were the Weather Service, was the summers of 68 and 69 I spent at the old district center. And that convinced me that's really what I wanted to do. I had an interesting opportunity as I was finishing up as an undergraduate. There was a hiring freeze in the Weather Service, and the Weather Service tried to sneak me on. So I got hired around Thanksgiving of 1969 by Southern Region. They didn't have a place to put me. They were just going to move me around temporarily. I said, that's fine. And by Christmas time, they got caught and I got fired before I even started. So it's like, what do I do now? I talked to some folks at the Severe Storms Lab. I was going to OU undergraduate. And they said, well, you can keep working for us. I was working for them part-time, but they said you ought to go on to graduate school. So I stayed with the lab until the fall of 1970, went to grad school out at UCLA, and 3 or 4 years later, I was ready to get picked up again, and the Weather Service couldn't find any place for me except the lovely metropolis of Detroit, Michigan.
Oh, boy.
Oh, wow. Yeah. So I went there. We were in the original terminal building of Detroit Metropolitan Airport, this little building that was built in 1933, and that's where the Weather Service was located. So I spent time there. A year later, I had an opportunity to go to the old Severe Local Storms Unit at the National Severe Storms Forecast Center in Kansas City, and I got selected. I was very fortunate. So I was able to move to what I really wanted to do, and that was in the summer of 1974. And I have spent virtually my entire full-time career in severe weather with first what was called National Severe Storms Forecast Center, and we transitioned to the Storm Prediction Center in 1995. Stayed in Kansas City until January of 97, moved down to Norman at that point. So almost all of my career, which is over 40 years, has been with severe storms.
So, Steve, you just missed the super outbreak then.
I just missed it. I was actually at Detroit that spring on April 3rd, April 4th, 1974, and did not get to Kansas City and the cells unit until very early July in 74. So I just missed it.
Wow, that event changed my life. I am a child of the super outbreak. I was a senior in high school, and they gave me 3 days off to go volunteer with my ham radio gear, and that I saw things that changed my life. So it's interesting that you just missed that, because Steve Weiss, you know, the name and SPC in cells, it just goes together. So I somehow thought maybe that you had hopped on board in Kansas City right before that, but it turns out it was right after that. So
correct. Not quite. I didn't quite make it. There were tornadoes close to Detroit that night. They were in Windsor, Ontario, just across the border. But it was certainly a concern. I remember that particular day as being considered to be quite unusual in Michigan, because at that time the State Forecast Office had responsibility for all of the state of Michigan, including the Upper Peninsula and all of the Lower Peninsula. And the forecasters that day were dealing with severe thunderstorm potential in southeast Lower Michigan and winter storm and near blizzard conditions in the Upper Peninsula. So it was the vast suite of extreme weather across parts of Michigan that day. And I still remember that quite vividly.
Yeah, wow.
So, like I said, much of my time has been spent in severe local storms. I got my, I guess you could say, my dream job fairly early in my career. And from my perspective, this is what I wanted to do. I couldn't see going to anything else. This is how I wanted to spend my career. So I was very fortunate to work up through the ranks as forecaster. At cells, I spent about 10 years there before I became a lead forecaster in 1984. I spent some time, the previous 6 years, actually splitting time between aviation weather forecasting, because we had the regional aviation unit that covered parts of the Midwest. And we did not have a career ladder at the time to stay in cells to go from an assistant forecaster to a lead forecaster. So you had to go out of cells and work in aviation, wait your turn, and then have an opportunity to move up. But I was fortunate. The director at the time, Fred Otsby and Alan Pearson, both of those directors, allowed me to work some of my time in the cells unit while I was technically an aviation forecaster. So I was able to get my severe weather fix, so to speak, on a fairly regular basis prior to becoming a lead forecaster in 1984.
Wow, that's amazing experience. And I'm curious, with all of those years that you spent in and near the unit as it's developed, with all the changes in technology and changes in the science of forecasting, what have you seen have been the most major developments and differences between how SPC functions today and when you started back in the 70s?
It's very amazing. I'm grateful to actually have gotten there when I got there in the summer of '74, because some of the techniques and methodologies were very similar to when the cells unit started in the early 1950s. When I got there, we still used typewriters to type up watch messages on carbon paper forms that would be given to someone called a communicator who worked the teletype machines. And they would cut a teletype tape to issue the watches across the various circuits to reach all of the country. Kansas City at the time was an FAA communications center, and they had all of these banks of teletype circuits for both observational data and forecast data that they controlled. So if a watch was going out, you would type it up, like in 1952, hand some of the carbon copies to the communicator. They would cut a teletype tape, and then they would break the circuit if anything was transmitting and say, sorry, watch coming up. And then they'd ring the bell a few times on it and send the watch out that way. We continued to draw up the watches on hand-drawn maps. We had small straight edges that were marked with distances proportional to the latitude on the maps. And we would use that to draw up the watches by hand and then determine where were the anchor points manually and use that to define the watches. There was very little computer opportunities at the time. Within the next year, though, we had some electronic systems that would allow us to get rid of the teletype tapes and compose our outlooks, our status reports, and the watches on these electronic screens that would automatically transmit the products. So I saw the tail end of some of the 1950s when I got there, and we began to move forward with a variety of new approaches and new equipment in order to begin to, at the time at least, modernize a bit. The real change occurred in 1980. By that time, the University of Wisconsin had already developed early versions of Mercatus, the Man-Computer Interactive Data Access System. And we had an early drop on that from Madison that will allow us to see real-time satellite imagery, animate it, and display basic information on top of that. That led to having our own system developed by Wisconsin folks called the Centralized Storm Information System in 1982. And that was the first fully interactive computerized system in the Weather Service that we had at cells. And it tended to revolutionize the way we approach the forecasting process, because prior to that, we could not see satellite imagery except in still images, hard copy images. We would have a film strip loop made every 6 hours of the hard copy images in order to see animation of weather systems. But when we got this, I guess we could call it specialized, souped up Mercatus system that was designed for cells, all of a sudden we could see weather as it was happening. And that made a big difference in a lot of our analysis and forecasting process. And that pushed us on the road to actually observing the weather associated with cloud patterns as it was actually happening.
You know, that reminds me so much of even just this past year, as many of us have had the opportunity to experience the GOES 16 data, and even just seeing the increase in the spatial-temporal scale. You can see so much more than you were able to see before. I'm sure for you, it must have been beautiful looking at that and then looking back on all the development you've seen to get to this moment where you're probably still looking at this stuff and learning new things, even with the decades you've had at the desk.
No, that's one of the neat things that we've all been able to experience is the technological advancements, the scientific advancements that tend to go hand in hand, that we know so much more about atmospheric processes, and with the technology, we're able to get our hands on information so much more quickly. Of course, a lot of the challenges now are what to do with all of the data that we receive on such a frequent basis. Our concerns way back when were, well, I don't have enough information to really know the details. This is all I have. I'm going to have to go with this and make a forecast. Now the challenge is we have so much data, so much potential information. How do we mine it in intelligent ways such that we can access the truly relevant information in a timely manner? So instead of saying, I don't have enough data, we have more than enough data. Folks have said we have either a fire hose or a water cannon of data to deal with. But our challenge is to use it in an intelligent way and gain relevant information when we need it.
Absolutely. So how do you do that? How do you slice through to find the relevance when you have just this sea of information coming at you? That is a grand challenge, not just for us in weather. That's a grand challenge for many today. So what have you guys been doing to try to make that meet that challenge?
A lot of what we have been doing, and we've been fortunate in some ways that we have at a national center like SPC, we have access to data sets that not everybody has an ability to get their hands on. We have a lot of sharp people here at SPC, both within our forecasting ranks and within our science support branch, who are working very hard to develop new and innovative ways to process, play, and visualize information, to extract relevant information, so that in some ways we can condense and summarize what's actually important, or what we think may be important for a given weather situation. Some of this is related to, as James said, numerical models, but we have to make sure that we remember, and this is something I try and teach a lot of folks, especially students, the real atmosphere is more important than the model atmosphere. The real atmosphere is what counts. Even though we may have more data from models and easier to display at every seemingly square inch of the model atmosphere, we still have to pay the closest attention to the real data.
Absolutely. Well, I don't want to monopolize the floor here. We have James and our guest weather brain. I'm sure that you all have lots of questions for Steve.
So I went to Kansas City for the first time to SELS. I want to say, Steve, this was in 1979. And the first thing that hit me was that teletype room. People, you described the process, but people have no clue how it worked back in those days. And you had the communicator that made those punch tapes that ran the teletype circuits. I mean, it was this clacking noise. But you know, it's funny for those in the TV weather offices. We had the NOAA weather wire, which was a teletype. We were an end user to all that, and you could almost tell by the way those machines were typing and clacking away if the circuit was being broken and a warning or a watch was coming. It was so different back then. People had no clue. And the other thing, I remember that, Steve, back in those days when watches were issued, it would be, there's a tornado watch in effect for 50 miles either side of a line, from 40 miles southwest of Birmingham to 70 miles northeast of Atlanta. Remember those days?
Oh my gosh. We that is what we did manually, where we would analyze our surface map by hand. We would identify the threat area, and then we would lay out a parallelogram approximately on there. We would draw it up, and we would then, using these straight edge, which I actually have some here. I could bring one and show it to you if you wanted to see it, because I still have some of these almost museum pieces in my office. We would then manually determine where was the watch located in terms of either side of a line, east and west of a line, and where the anchor points were. And admittedly, they were approximations. We were not that exact at the time, but that's what we would do. And that's, as you mentioned, that's how the information went out. And if you didn't know your anchor points, you had no idea necessarily where the watch might be.
It was a different era back then that people just don't understand. I was going to say, when did the convective outlook products begin? The slight and the moderate and the high. Was that in existence when you came in 74?
No, when I came, we had outlooks, but those particular categories were not used. The equivalent outlooks actually began in 1955. Right after the cells unit moved from Washington, D.C. to Kansas City in 54, what was called the cell synopsis was issued once a day, about 3 in the morning, to outline areas where there was a severe weather threat across the country. That was the beginning of the convective outlooks. The convective outlooks evolved into the 60s and 70s. And when I was at cells, when I arrived, they did not have those particular categories. They said that there would be isolated severe thunderstorms, scattered severe thunderstorms, numerous severe thunderstorms, using the language to describe shower and thunderstorm coverages that were used by the aviation community. The terms slight, moderate, and high did not come about until the 1979-1980 timeframe, when we revised the definitions and criteria, largely based on information we had from the 1974 super outbreak in terms of coverage of severe weather events. We said that's going to be the high-end coverage. What is it in terms of reports per unit area? And in the process of doing that, we also revised the categorical names because they no longer meshed with the isolated, scattered, and numerous coverages assigned to thunderstorms and showers. So it's been since, what's it been, about 37 years that we have.
What are your thoughts, Steve, on the new expanded version of the convective outlook with marginal and then slight and enhanced, or enhanced, slight, moderate, high? What are your thoughts on the new categories?
This allows there to be more of a one-to-one matching between the underlying probability outlooks and the categorical outlooks. We had started to issue the probabilistic outlooks publicly in 2000, and we've continued to refine those as we have moved along from that time. And clearly there was more information if someone was willing to dig a little deeper to look into the probabilistic outlooks. One of the things that we found was that the slight risk category covered a fairly wide range of probabilistic threats, particularly on day one. And we weren't providing as much information in terms of delineating the threats with this relatively broad slight risk category that encompassed a broader range of probabilities. So after a lot of discussions, both internally with folks in the social science community who focus on communication and risk communication, decision was made to add more resolution in the categories and have them match a little more closely what is available in the probabilities. The challenge that we have, and Kim knows this and everybody knows this, but Kim has studied it, is it is very, very challenging to come up with single words to convey all of the details about specific severe weather threats that you may want to pass along. So what are the best terms? Clearly, people will say, well, why slight, moderate, and high? Admittedly, those were developed back at a time when we did not understand social science. We did not understand risk communication. And in fact, at that particular time, the cell's outlooks did not go out to the public. They were strictly internal to the Weather Service. So for our purposes, the terminology was reasonable because we didn't think it was going to get widespread dissemination. Boy, how we were wrong on that. So with time, we became aware early on, slight risk. Well, that sounds like we're downplaying it. Yet we knew at the time slight risk was meaningful, that there was a threat of severe. It had originally started in 1979 as a low, moderate, and high, 3 categories. But some folks said, oh, low doesn't sound good, you should change it. So somehow, instead of changing it to something perhaps a little more meaningful, we went from low to slight. I don't know why at that time. It didn't appear to be really any better, but it became entrenched in the nomenclature. And for emergency managers and broadcasters, once it started to leave just the internal workings of the Weather Service, folks began to learn, oh, a slight risk is meaningful. There is a chance of severe, and we never changed it. So we have the slight, moderate, high. We felt that we needed more definition, especially between the slight and the moderate. And how you come up with a word, initially internally, it was called an enhanced slight risk, not an enhanced risk. But we wound up dropping the last name of it and just stuck with enhanced. So we wanted to keep the moderate and high the same because they had such recognition across the weather enterprise. But how do we come up with other terminology? And as Kim knows, it's so difficult to just come up with words. So we've tried to use numbers as well as colors to indicate the varying threat levels, and hope people will pay attention to that as well as the wording to try and clarify what's the order and what is more threatening.
Yeah, it turns out there aren't very many pairs or sets of words in the English language that build into sort of a nice 5-tiered system. We have a lot of 3 tiers, but we really don't have very many that go beyond that. And it's so interesting what you're talking about with the history of there being a low. There's sort of the low, medium, high, or ordinal progression, which is so common in our language. But it's not something that you want to say as a risk communicator, that the risk is low. You are trying to convey that it's something that's important and worth paying attention to. So really the challenge always was that you needed a 3-tier system that still at each level conveyed that there was risk that needed to be attended to. Low doesn't really do that job. So I don't envy you the task of trying to find something that's perfect. And you also at this point have what our close colleague at the lab loves to talk about, the sort of institutionalization of the system. So even if it's not perfect, you now have a lot of people who are well adapted to it. So just upending it wouldn't have been the easiest thing either, because then even if you only have 80% of the people who really understand it, if you go to a new system, 100% of the people are going to have to learn the new system. So it was always a challenge when you were going to try to make a change.
We spent more than 30 years trying to educate the user community on the terminology. And we've made progress, particularly with folks who pay attention to the weather. If they know they're in a slight risk, some will not downplay it, even if the wording is imperfect. But we know if we make wholesale changes and upend everything, then we've lost everybody. And how many more decades will it take to educate people so that they become familiar and comfortable with the terminology? These are tough questions.
They are tough. I mean, the other option, you can try to find something that's just completely naturally understandable. Interestingly enough, you can look to other systems that our listeners might be familiar with, and you'll see that over time, other kinds of risk communication agencies, they've tried to make their message simpler. So instead of broadening the classes, they've actually gone to something more like our watch warning system. A big example of this that we may be familiar with are those color codes that we used to face for terrorism threat when we go to the airport. So there would be the sort of, blue, yellow, orange, red, all these colors in the system. And it was discovered that one of the challenges of that is that they never really wanted to go down from orange. Once they were at sort of this tier 4 level, it was really hard to come back down because they felt that would signal, to folks who wanted to do us harm, now is the time. So they actually sort of just went to a system where if there's an elevated threat, they say it's elevated, and then there's a clear time where that ends, and that's sort of it. So they kind of reverted to the watch warning system away from a more tiered system because of those unique challenges. Clearly, we have a sort of different set of challenges in weather, but I thought that was really interesting. While we're getting more complex, a couple of other fields are trying to really simplify.
This is something that we need to continue to work on, obviously. I think, James, you're at the forefront in risk communication to the masses in Alabama, and you bring home the point of how important it is that we communicate effectively so that the user community can make appropriate decisions and responses. We've learned a lot through the decades, I believe, but there's still, as Kim says, a lot of work to do. Part of it is associated with the legacy approaches that we have used for many years, and some people are very comfortable with them. But we always have to find ways to improve. And you've been a leader in that. Mark, you have some comments too.
I was just going to ask, one of these things that I've talked about with my listeners lately has been this issue of where's the right balance between who has access to what information. And I'm curious, clearly in the days of the teletype, that limited who saw the end message that you guys were issuing. And I know James can't post something about the Bama Boons online without all the flat earthers and chemtrail people coming after him. But I do
wait. What'd you say, Hank? Hang on. Hang on. I got to play my joke.
Chemtrails.
But Steve, I was wondering, do you think that centers like the SPC might better serve the weather community if they were limited in their access to people, for instance, that are on NWS chat, so that the people you're communicating and can more easily share the information you want to convey, which sometimes is more difficult to just somebody that's going to throw it out on Facebook or Twitter or whatever? Might there be value? And I don't know if that's the right answer for access to your material to be more limited, and then people like James or people like the local offices are the ones who do the final communication.
Well, I think what's happened is once the genie's out of the bottle, it's very difficult to put it back in. And this is part of the challenge. Everyone loves the internet for the ability to access so much information very, very quickly. And we learned probably by late 90s, at least early 2000s, that by putting our information out on the internet, like most weather service offices and centers, all of a sudden our audience base became very, very broad across the spectrum. Previously, our information was much more restricted, and we found that we can have positive results because we are sharing information with groups such as emergency managers and broadcasters much more quickly. But then we also find that anybody with access to the internet can see what we are forecasting. Some folks are pretty savvy and they can learn to interpret it. Other folks may take it on a more elementary level in that case. But I don't think we can turn back at this particular time. And we gather from feedback that we receive from just the general public and other users that many folks really like having access to the information. They believe it helps them prepare for severe weather events in advance, that they can help their family members and their friends. And this is the way the world is now, and it would be difficult to change that.
All right. So my follow-on question is, now that everybody's going to have everything, what is the role of, or as you've seen this evolution take place, do you see a place for AI and machine learning and what the SPC does in trying to deal with that fire hose, if you will, of all the data that's coming in to process it in a way that probably the human brains may never be able to process it?
Oh, yes, yes. We have some beginning work that we are exploring approaches to machine learning in terms of model data sets and model fields that may statistically be more related to convective storms such as thunderstorms. We're working with a group from CAPS and NCAR that is using machine learning techniques to data mine high resolution ensemble systems for hail prediction and hail size prediction. And we need to explore a variety of scientific and mathematical approaches in order to find out which methodologies may be the most productive and bear fruit sooner. Because as you said, the databases are becoming so large and there's so much information, it is difficult for humans to wade their way through all of that in a short period of time. Many have learned to focus on specific elements of this big data, so to speak, from a human perspective, but we're continuing to work on statistical methods in order to extract the relevant information from these very large databases and apply them to severe weather forecasting threats.
All right, let me shift gears here, Steve. The most memorable severe weather outbreak you've ever worked at SPC or cells?
Oh, there's several of them. Some of them were early in my career, which means they probably had a little more impact on me. I think one that I worked was the May 31st, 1985 Memorial Day outbreak in Ohio, Pennsylvania, Western New York. That's a pretty fairly unusual area for major tornado outbreaks. It was my second year as a lead forecaster at cells, and it was a challenging case, as they often can be in that part of the world. We didn't have a lot of information, obviously, at the time. We had some, particularly satellite information. Again, we had the Mercatus system at the time, but we thought that there was at least some tornado threat on that day. I had pushback from some of the local offices in that area, Cleveland and Buffalo, saying, why do you want to issue a tornado watch? We don't get tornadoes in this part of the world very often. And it was right at the end of my day shift. So again, it was before the internet. It was at a time where I issued a tornado watch toward the end of the shift and then briefed my relief and I left. We had relatives visiting us that time. It was my last shift of 5. We went out that night. I had no information from the news at all. And it wasn't until the next morning I woke up and looked at the Kansas City newspaper and had a story on the front page that said, tornado outbreak in Great Lakes area, at least 45 killed. And I went into a minor shock and reread because at the time we couldn't keep up with any weather information. So you issued your forecast, you went home, and unless the weather was local in the Kansas City area, that was it. You didn't know anything had happened, and I didn't know anything had happened until the next day. And then it was a struggle to find out from television news and radio news exactly what was going on. So that was a real eye-opener to me because, quite frankly, on most days, I don't think I anticipate a large number of fatalities. When I have thought it would be possible, more often than not, it doesn't happen. Other times, I'm thinking there may be some tornadoes, and it's problematic as to exactly where they strike. You know that from the southeast quite well. I can think of another case in 1998. It was the February 21st, 22nd tornado situation in Central Florida, where we had been under there was a threat of severe weather all day in parts of the peninsula. Not much had materialized. We had watches out. I came on the swing shift. Local offices were thinking we don't need watches anymore. The threat is diminished. We haven't had much. We looked out in the Gulf, and there were storms that were weakening as they were moving through the eastern Gulf. And there was a lot of question as to whether there was still a severe weather threat. We looked at a piece of observational data that you will appreciate, James. We looked at the 0Z Tampa Rayab.
Yep.
And it had some steep lapse rates. It had a clockwise turning hodograph. It had large values of low-level shear and helicity. So we had a dilemma. Storms were weakening. We had a watch that was expiring. The storms over the peninsula had turned to heavy rain in the northern part of the peninsula. The storms in the eastern Gulf were weakening. Cloud tops were warming on the satellite imagery, and the lightning data were indicating a decrease in lightning activity. So what do? You know, we coordinated with the Tampa and Melbourne offices, and we said, we can't guarantee there's going to be severe, but that Tampa sounding still has a great deal of potential. I'm worried if we let the watch expire and say, well, we'll issue one a few hours later if we need it, we will have lost a lot of people from paying attention. The message would go out, the watch is expired, the threat is over with, and people would not pay attention into the nighttime hours. So after coordination with local offices, we decided to reissue another watch across the Central Florida Peninsula, not knowing what was going to materialize, but there was still potential. And we were willing to take the chances in a probabilistic sense. Well, it turned out as soon as those weakening storms approached the West Coast, the Gulf Coast of Florida, as soon as they hit land, they started to intensify and they started to rotate. And they moved all the way across the peninsula, inflicted considerable damage around the Orlando area, not Orlando City proper, and killed 42 people in the overnight hours. And it really showed us, to me at least, that sometimes the potential is going to be realized, sometimes it may not, but we have to take that into account in our decision making. And it just so happened, we found out later that the head of the Florida Emergency Management organization was Craig Fugate, who later became head of FEMA. And that left a big impression on him in terms of nighttime tornado threats, at least in Florida, which of course can transfer to all of the Southeast. So that was an interesting day that we recognized it wasn't just a meteorological challenge, but it was a risk communication challenge in terms of people being under a tornado watch much of the day, how do we handle it when we're not sure of the overnight threat? And it showed that we had crossed some threshold from when I started, where we were just forecasting the weather. We weren't even thinking about risk communication way back. And by the time we reached that point, we were clearly more aware of what the needs were in terms of not just the science, but the service that we were providing from SPC.
I'd like to ask this question too, Steve. A lot of young people listen to this show. These are maybe students that are in meteorology in college. They want to be the next Steve Weiss. So what advice can you give them this day and age?
Oh, be a lot smarter than me. That's one approach. I was very fortunate. I was able to follow my passion. And I got very fortunate that I was able to be selected. My sense has been that you have to continue to learn. You have to continue to prepare yourself, because you never know when opportunities are going to arise. So you have to prepare yourself to take advantage of opportunities when they occur. We can't predict them necessarily, but whatever you're doing, do the best job possible, regardless of how menial or high level. I'll give you an example. When I first got to Detroit as a beginning intern, we had 4 vacancies in our old Met Tech section. So all of the interns were doing Met Tech jobs. We were not doing forecasting. And I actually, on April 3rd, 1974, part of my job was to serve as a local communicator with teletype tapes in this small communications room in the Weather Service forecast office. And I could have, said, oh man, what am I doing this for? I can't believe it. But I actually felt at the time that if I can learn many of the jobs literally from the ground up, it will benefit me along the way. And I had confidence that I wouldn't spend the rest of my life moving teletype tapes around. So I think that was a key thing from my perspective. Take advantage of every opportunity, whatever job you're doing, do it as well as you can, because it develops very good work habits, a good work ethic, and people will notice if you're doing a good job regardless of what it is within the weather enterprise. But again, I was very fortunate that opportunities came up. Most of the time I was successful, but there have been times that I was not successful and did not get a promotion when I was hoping for one. So you just have to follow your passion, work hard, continue to learn. I know it sounds kind of quaint in some ways that we should be lifelong learners, but as you well know, that's the only way we're going to keep up with things and improve, because the atmosphere is very unforgiving and it doesn't give up its secrets easily. We have to stay at it.
That's such a great quote. The atmosphere is unforgiving, and we have to stay at it. That is very wise advice for all the young people listening. So I actually did get a question slipped under the door from Patrick Marsh, who is working in ops and couldn't join us on the panel this evening, but he did manage to slip one to me. So I have a question for you from Patrick. What of the following do you think has advanced operations, severe storm forecasting more through the course of your career? These are 3 difficult options, Steve, so I hope you're prepared for this. Introduction of the WSR 88D network. Number 2, computing improvements and introduction of CAM guidance. Or 3, infusion of more science directly into operations. And he concludes with a note, oh, and any plans on retirement.
Well, I'm not planning on retiring the WSR 88Ds, if that's what he was wondering. All of the things that Patrick mentioned, they all form part of the pieces that we need to improve our understanding of meteorology and forecasted warnings. WSR 88D provides us with unique observational data that we never used to have. So that is a way that we are applying new science and technology, but some of that has its foundation in scientific advancement in terms of the dynamics of thunderstorms and the use of more sophisticated radar in order to analyze and interrogate what's taking place in storms. High resolution modeling approaches have allowed us to advance our ability to predict at times hazardous weather. But as was discussed at the beginning of this show, it times maybe didn't help us a whole lot with this last snow situation in parts of the Southeast. So we have to recognize, of course, that there are times that the models will be wrong, the ensemble systems may not span the full range of probabilities that the atmosphere tends to follow. All of these things provide us with core information, but I would say it's the basic science and the application of science that allowed us to move ahead with the development of WSR 88D, science and engineering, that allows us to move ahead with more advanced numerical weather prediction systems. And it is the application of scientific ideas and scientific concepts that continue to move us ahead. We translate that science into tools, concepts, and technologies. And plans for retirement. Oh, sure. We all think about that. Especially, I've told people that it's highly likely I'm past the midway point of my career at this particular point. But it's also like, well, I grew up in Chicago, so Cubs fans could relate to this until 2016, but now it's come back again. It's always, well, maybe next year, I'll hit the jackpot. And I admittedly, I'm thinking about that. I've been thinking about it for a few years, but then I also think, golly, look at all the neat things we get to do. Look at all of the advancements we get to test in the hazardous weather test bed, all the things we get to try in SPC operations to improve things. And the same excitement and fascination I had a very long time ago as an undergraduate, those feelings don't really go away. I still get excited. I get excited every spring. And I suspect that's not going to change.
So let's do this. And I got more questions, but we got to stop for just 1 second. We've got Tony Rice in the astronomy report. We've got one email that's an audio email from our friend over in Estonia, and we'll come back and kind of wrap things up. I do want to ask about the relationship, Steve, with SPC and the local weather service offices. But before we do that, let's take a quick break for Tony, and we will be right back as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
The Geminid meteor shower peaks this Wednesday evening into Thursday morning, December 13th and 14th. The Geminids are worth looking out for a couple of reasons. Moonlight won't interfere this year. The moon doesn't rise until about 4 a.m. local time, and even then only a small sliver will be illuminated, about 17%. Unlike other meteor showers, whose numbers peak sharply in the hour or so before dawn, the Geminids are active pretty much all night. And that's great for families or for those who aren't all that interested in getting up at 4 a.m. for the show. That being said, though, the number of meteors visible is expected to rise the closer you get to 2 a.m. local time. So if you're looking for the best time to observe, set your alarms. And like any other meteor shower, the less light pollution, particularly in the eastern skies, the more meteors you're going to be able to see. Rural observers may see in excess of 100 meteors per hour. If you're in the suburbs or a more urban area, you can expect to see about half that. Something else that sets the Geminids apart happens as the constellation Gemini, where the shower appears to radiate from, rises about 7 p.m. local time. You'll see two bright stars, Castor on top and Pollux below. And the meteors appear to emanate from around Castor. For about the next hour or so, you probably won't see a whole lot of meteors, but those that you do see have the potential to be spectacular. During this time, the meteors are reaching us at a lower angle, skimming the top of the upper atmosphere. This tends to produce longer-lasting meteors with longer streaks. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
So Aubrey is not here, but we still got at least one email we can play this week.
Letters. We get letters. We get stacks and stacks of letters.
All right, before we go back to Steve here, let me throw a little audio from our friend Tarmo Tantelsu in Estonia.
Hello, WeatherBrains. This is Tarmo Tanilso from Nagoya, Estonia, with a quick update. Well, Europe has been quite a bit under the weather, except me. It's been occasionally windy, but not even remotely the kind of thing that has been happening in Germany, France, UK, and so on. In fact, just today, a pretty wicked cyclone made landfall over France, and it also has been causing some really nasty wind gusts. We're talking hurricane force gusts here, especially at the mountains. And speaking of that very same storm, over the weekend I noticed something that made my head hurt. My veins at the top of my head were bulging. Black steam was coming out of my ears, and I was pretty close to writing a letter to my local representative in the European Parliament to beg to do something. You see, as you might know, there are plentiful of storm names available over here in UK and Ireland, in Scandinavia, in Germany, in Finland. They even have put a name on a terratia. But now there is a new one in the club, comprising of France, Portugal, and Spain. They now have their own storm names, and according to them, the storm was named Anna. In fact, I'm right now looking at the adopted the Vortex program weather charts, and the Germans had called the very same system Ives or Uves. Not quite sure how to pronounce it. But, well, once again, a storm with multiple names. Guys, okay, I get it. We have many languages, we have many cultures. But given that these types of things don't affect only one country or one region, could we finally come on an agreement on a union-wide naming scheme? Guys? Well, that's my today's Andy Rooney moment. Back to you now from Lago Estonia. This was Tarmo, the International Accelerant Tanilso.
Yes, the International Accelerant. Ladies and gentlemen, we just like to hear Tarmo talk. So notice I have changed to my TV duds here. So Steve, back to you now. Tell me about the relationship now between SPC and the local weather service offices. Good, bad, improving? What do you say?
I guess it depends on your perspective. As you know, I've been in this business for quite a long time, and particularly during the watch issuance process, we have been coordinating, collaborating with field offices seemingly forever. Certainly from the time I got into the sales unit, we have coordination calls with local offices for every severe thunderstorm and tornado watch that is issued, and occasionally for some that are not issued, that we may not be sure if the threat deserves one, and we will contact local offices and have a discussion. So from a watch perspective, I think that's always been pretty good from my perspective, in part because of my own personal views. We're one weather service. The public is looking to us to work together to provide them with the best service possible. There's been more need to collaborate with local offices in more recent times, particularly on the overall forecast, including outlooks, as well as watches. And the process can be challenging in part because there's many more local offices than we used to have. Back when I started, we had the WSFO set up, and we would coordinate with one office per state. Now there can be 4 or 5 offices in a particular state, and it can take a little more time, but we do have to work at that. We're trying to find ways to use the collaboration chat tool within AWIPS to talk to local offices, local forecasters prior to our outlooks going out. If we are anticipating making a change within certain CWAs, county warning areas of WFOs. And I think that there's some improvements that are taking place within that realm so that we can communicate more effectively with local offices. But as you know, severe weather can change rapidly, and to keep the communication going, it takes additional effort on everybody's part. And this is something that we're all continuing to work on. What I usually do when I give talks to local offices, local forecasters, I encourage them to contact us if they are assessing the situation differently than we are. Let us know ahead of time before the watch goes out if you have a different assessment. The sooner we get on the same page and at least discuss things, the better off we'll be. So it's all about communication and making sure that we understand everyone's assessment of the situation and what the threat level may be from various perspectives.
And in terms of communication, you are now a broadcaster because of this 800-pound gorilla we know as social media. Thousands and thousands and thousands follow the SPC on Facebook and Twitter and all these platforms. How has that changed your world at SPC? Really, you need the broadcasters to some degree, but then again, you can take this stuff straight to the public. How has that altered operations there?
It's changed our perspective, James, clearly. We used to think that we were only talking to other weather service people and nobody else saw our products until a watch went out. We're now very much aware that lots of folks through a variety of social media or just going to our internet page can get information directly from us. And that has changed our assessment of how we communicate words, and that we have to be very, very careful in the use of language. Let me give you an example. If we mention a couple of days in advance with, say, a day 2 or day 3 outlook, a threat of tornadoes, some folks will interpret that differently. Some will read into it, do they mean that there's a potential for an outbreak? Do some interpret it as meaning we think there may be widespread tornadoes, or will others interpret it as meaning, well, just a few tornadoes? So we have to be cautious in the wording we use within our outlooks, and we want to be consistent in terms of the wording we're using as we are updating our social media posts from SPC as well. We clearly depend on you and your fellow broadcasters to really provide the informed interpretation to a lot of folks out there who are looking to you for the final word, so to speak. But we have to be aware that there's so many avenues for communication now that what we say at SPC is read by many, many people, and we have to make sure that we are providing very consistent messaging ourselves that will be hopefully interpreted in a more consistent way by all of our partners and users out there. It's a challenge, I will admit, and we all have to do a good job together. This is where the real benefits will come from.
All right, Kim, I'm going to let you take it away because I got to slip next door over the old TV studio here.
Sounds good.
Yeah, James, you have real work to do now.
Well, to some degree. Thank goodness no snow tonight.
Oh, that's good.
Yeah, thank goodness. I don't know if that neck of the woods could take that twice in a week span. So unfortunately, we had to lose James before he could give us his pick of the week, and before we could go around and do picks of the week. Do either of you have a pick of the week?
Well, Kim, I'll say that since James has left and Bill's not here and Rick's not here and Aubrey's not here and Brian's not here, I get all their picks of the week. So
you have a lot of picks to share.
I have one for my own, but I know these 5 people would have wanted me to put this one pick out there. Actually, I had hoped to mention the top of the show, and James really wanted to talk about, needling about the snow forecast, which is fine. I don't mind that. But Bill mentioned briefly last week, and one of the reasons I came on the show was to mention a survey that I'm doing that's related to podcast and the Weather Ready Nation. And this past year, we did this podcast month. I think it was actually right before you came on, joined the WeatherBrains group there.
Yeah.
And one of the things that we did is we all became ambassadors to the Weather Ready Nation. Now, I'm going to be presenting on that specific topic about the role podcasts play with the Weather Ready Nation at the upcoming American Meteorological Society in January. And I'm doing a brief survey, and I'm doing it for each of the podcasts that have kind of done this thing. But you guys certainly have a very big audience, and I would just ask that your audience stop when they can, open up the internet and type in bit.ly/WeatherBrains dash or hyphen, whichever nomenclature you want to use, WRN. So bit.ly/weatherbrains.wrn, and take 60 seconds to complete that survey. It helps a lot, not just for my stuff, because I've had this conversation with a lot of people, but it will help all of us podcasters to do a better job at making sure that we're understanding what you're receiving compared to what we think we're telling you, and hopefully make that relationship more fruitful for everybody involved. So that's the pick of those 5 people.
Okay, wonderful. Yeah, I actually had seen the survey. Bill briefed me on it, and that was his pick last week, was your survey.
Exactly.
So I had some questions for you. I was hoping to get a little bit of detail about maybe any early findings, but we should not share anything you have so far with the audience as to bias.
We don't want to taint them, right? That's right. And so
exactly. That's social science practice, that would be.
Exactly. So my personal pick of the week is the National Operational Hydrologic Remote Sensing Center. Now, NOAA's very good at having acronyms, so there's another one, the NOHRSC. But they have a great site for people that are interested in snow and snow tracking, and I'll make sure that, whoever's in charge of the links has that links to add to the show notes, because it was very useful in actually some of the diagnosis I've done in following up on the snow event.
Okay, wonderful. Well, thank you for those picks, Steve. So before I leave you, you at least had taken several people's picks. Are you through then with all of your picking?
Those 5 people had one pick, and I took my one additional pick. Right.
Wonderful. Okay, just wanted to be sure. Thank you. All right. So, Steve, how about you? Any picks of the week? I don't know if we'd warned you that you should prepare a pick. I could stall if you need to think of something.
Or we could ask Patrick what he thinks he wants to provide, and he can send it in to you. Because apparently he said he was going to be listening to this out in SPC operations.
Yeah. So he could offer something on behalf of all of SPC operations if he can get it in the next couple minutes. Patrick, you have a challenge.
So the pick for the SPC office there is the SPC website, which is SPC.
If this listening audience has never been to the SPC site, that would be impressive.
Oh, here comes Patrick. Here he comes.
Patrick.
Come on, Patrick.
Rushing in with his pick. Hi. Do you have a pick for us? Steve offered you his spot. Can you hear me?
Yes, he can hear you, but I think he's deferring.
The We'll go with the winter mesoscale discussion that the lead forecaster Rich Thompson just issued.
Oh, fantastic! What mesoscale discussion number is that? Do we have a number?
Is there a number on that?
The now famous MD.
He doesn't know right offhand. We'd have to go to the SPC webpage to take a look. Is this for lake effect snow? Or is this a snow squall in the Northeast? Warm advection. Okay.
Okay.
Well, this is good because we started out the show talking about snow in the Southeast, and we can end it by talking about snow again.
Yes. Actually, I'm going to offer with my pick of the week a place where there is lack of snow. My pick of the week is a story by Deke Arndt, who I know that you know, Steve, from when he was here in Oklahoma. He was the
Yes.
sort of state climatologist here and used to write these delightful climate summaries for everyone who's subscribed to the Mesonet listserv. I really miss his charming wit with those. But he has moved on to bigger and better things. Now he's, gosh, isn't he a branch chief at the National Centers for Environmental Information?
Right, at Asheville, yes.
In Asheville. So he authors a blog on climate.gov, and he just shared this story of sort of this mysterious data that went missing from what's now known as Barrow, Alaska, but the original name Utqiagvik. I believe I'm spelling or pronouncing that correctly. I'm doing that or completely butchering it. But it's this great story about how their QC algorithm actually disappeared the data. And the punchline is that the temperatures have become so abnormally warm so quickly that the QC algorithm actually eliminated the data.
It melted the data.
Yeah, they melted the data.
Yes.
So the title of it is Alaska North Slope Climate Change Just Outran one of our tools to measure it. And there's some great data, some wonderful graphs contained in the story. One of the things I thought was the most interesting that I had not known before reading this story is for the North Slope of Alaska, most of the warming that's been experienced there happens in the late fall. So October, November, and December are where we're seeing the greatest departures from average temperatures. But for the most part, for the rest of the year, there's a lot of parity with longer term averages. But really, these are the months where we're typically seeing the greatest accumulation of ice. And so what we started to see over the years, of course, is this decline in the ice pack in the Arctic. And this just really speaks to that story because we have so little ice that's regenerating now. There are these positive feedback loop effects that create enormous warming deviations from average temperature. So for more on that, see Deke's marvelously written, he's just an excellent storyteller, marvelously written blog post on climate.gov. So with that, Steve, do you have anything else you'd like to add besides the MD?
No, this is good. We had fun tonight. It was good talking to you and Mark and James, and appreciate the opportunity to spend some time with you.
Yeah, well, it was great to have you on. I guess, was this your first time on WeatherBrains?
This is my first time on WeatherBrains. Patrick convinced me that this is something that everybody should do at least once.
It's true. It's true. We are where the party is, and I'm sure that our audience loved hearing from you, especially those folks who are intimately familiar with the SPC page, seeing your name signed onto so many products over the years. I'm sure that everyone was just delighted to get to know you, as well as many of us in the building get to experience the enthusiasm you've brought here tonight just all the time. Thank you again so much for being on the show.
Thank you, Kim.
Absolutely. And thank you, Mark, so much for being a guest WeatherBrain, especially on a night where we've really appreciated having one.
Oh, it's no problem at all. I'm glad I was able to fill some gaps. I certainly didn't fill any shoes, but add another voice to the mix tonight.
Yeah, and it was very much appreciated. All right. Well, with that, I'll sign us off. Thank you again so much, guys, and have a wonderful evening.
All right. Bye-bye.
Good night, Kim.
Bye.
All right. Thank you, Patrick. You were a godsend tonight.
Severe Storms Forecast Center was on. So be quiet here and just be sure that they're off. And yes, they're off, ladies and gentlemen. And the strange thing is that 14 people are still watching this. Wow. Let me turn my camera on. So, hello, we are simulcasting WeatherBrains and Song of the Night on the Tweeter or the Periscope. So, no, great having Steve Weiss on the show tonight. Fascinating. This guy has worked history. He joined CELS in the summer of 1974, right after the super outbreak. And I could ask that guy questions all night long. Great show. If you missed it, they'll be up on the podcast version soon after midnight tonight, probably about 1, 2 a.m. And for those of you watching on the stream on WeatherBrains, thank you guys. We'll see you all next week. Have a great week and God bless.